Hey guys, Gary Campbell back again. Got a small project here that may help a few of you out. If you can remember when I did my control box, I talked about using a relay board as a gender and voltage changer between 5-volt alarm circuits and the Acorn 24-volt inputs. So I wanted to take some time here to explain how I did that. On my drive alarms, I had to change both the gender and the voltage changer. Uh, and that's what I'm using a little relay board for. That my drive alarm circuits is 5-volt DC, normally open. My desired Acorn alarm circuit is 24-volt DC, normally closed. We could be using a 3 or 4 circuit opto isolator, but I didn't have one of those on hand. We also note that during the software tuning, my drive alarms could be set to normally closed, and I will probably do that in the future. Last note on this is that not having the alarm circuits properly set, in other words, having your encoder counts to trigger properly at the amount of error that you can withstand, or having the alarms connected to an Acorn Drive OK input negates any advantage of using closed loop devices. So whether it's steppers or servos, make sure that their feedback in alarm circuit is connected to the Acorn. What I used to do this, and mostly because I have them on the shelf, is a inexpensive Chinese Arduino type $4 relay module. They're available in 5, 12, and 24-volt DCs, 2, 4, 6, 8 relays per module. You can get them in high or low trigger voltage, so that means they'll either trigger with a ground signal or with their desired voltage signal, and that the physical relays themselves have normally open and normally closed terminals with a common in the center. Some of the more expensive boards, even like the ones that Marty showed, have screw terminals for all of those connections, but these inexpensive ones are made for the Arduino guys who use a lot of 0.1 tenth on center header pins. Closer look at this side of the board shows that we have the ground and 5-volt power to power the board up at the 2 outside edges, and in between them are 4 triggers for input channel 1, 2, 3, and 4. Also, there is a jumper. That jumper is used, it'll be in place on my system because I'm using the same power supply to connect my alarms as I am to power the board. If your drives output their own voltage, or you're using a different power supply than you are to power the board, then you would be removing that jumper and using one terminal for the common on your relay triggers. Last item on this side are the 4 LEDs. Each of these LEDs, in this case they are red, and they will be lit when that relay channel is active. Turning the board around to the other side, you can see by the legend on the bottom that the terminal to the left of the common, which is the center, is normally open, and the terminal to the right is normally closed. So I'm going to be using the normally closed terminals and just daisy chain between all of them to complete my alarm circuit. Now at the top left, you can see that I've got there's a red wire all the way to the left in my header connector, a black wire all the way on the right, and my 3 gray wires that are the triggers from the alarm circuits on the drives are in the center. So at the lower side, the wiring, my yellow wire, which is my 24-volt ground, comes into a common terminal, and then a purple jumper wire goes from the normally closed terminal to the common of the next relay block, and from the common or the normally closed terminal of the Y to the Z, and the Z to my yet unused terminal. And then on the far right there's a purple wire, and that goes direct to on my board it happens to be input 5, which is configured as drive OK. So what this means is my 24 volt ground yellow wire coming in is daisy chained through all those relays with a closed circuit until one of these drive alarms trigger this relay to open, and which it would close the normally closed terminals, but it would open my signal and it would trigger off the drive alarms. A little bit more information about the header connectors. You can buy these. That's a box of I don't know how many hundred of them. It's a couple of bucks, $2.50 I think on eBay, and it'll get you more than you ever need for all your future projects. That's the good news. They're relatively dirt cheap. The bad news is that if you can't find an inexpensive header crimper, and you end up looking around for one of these higher end Molex ones like this one, they're $250 and $300. So it might be worthwhile for those of you that don't have a crimper to use relays that cost a few bucks more that have screw terminals all the way around. So closing out this project, few things to remember. Remember that the voltage of the relay module must match that of what you're running through your drive alarm circuits. That normally closed is the best option for the input circuits on all of these cases. I am going to change my drive alarms via software to normally closed once I get in and start to do the tuning on them. But if you're just ordering them for drives that cannot be changed, remember that if your drive alarms are normally open, you use the normally closed pair of contacts on the relay. If your drive alarms are normally closed, you'll use the normally open contacts on the relay. And it is okay to mix and match these. I'm going to probably add a VFD fault as an alarm to this, so in case anything or a glitch or stall or something happens on my VFD, that it will also stop my machine. Last word of warning, that make sure you test these at a low speed to make sure that they work. I tested mine with a block of 2x4 between my Z and the table, between my X and the side plate, and between the Y in the frame, to make sure that each time I ran in or had that collision, that it triggered the alarms and stopped all motion on my machine. So that's about it to wrap up this part of the Acorn project, an explanation on the gender and voltage changer. And thanks for watching, and we'll see you on the next video.